Sometimes angles are graphed on a coordinate plane, just like you see on the left-hand side here. What happens is you start on what's called the initial side. Initial meaning that's where you begin. Usually the initial side is along the positive x-axis. So that is the part of the x-axis that has positive numbers, which is right here, and it extends forever. The terminal side, or where the angle ends, is going to come from the vertex, which is usually the origin, almost always, and extend in whatever direction it is that it's ending. So it could be up here, it could be down this way, it could be even over here, and you could have an angle that is quite large. You'll notice that between the x and y axis we have 90 degrees right here. So in quadrant 1 we have 0 to 90 degree angles. In quadrant 2 we're going to have 90 to 180 degree angles. In quadrant 3 we'll have 180 to 270 degree angles. And finally in quadrant 4 we will have 270 to 360 degree angles. And of course it'll be 360 if the terminal side comes all the way back around and it is laying on the initial side, in which case it will appear that you have no angle, but it can actually be written as 360 degrees. Which brings me to the next piece of information. Coterminal angles means that they have the same terminal side. So that's right here. Coterminal angles have the same terminal side. You can get to that terminal side in an infinite number of ways. And that's because you can continue to rotate around and around and around and add 360 to any angle to get coterminal angles. So for example, 120 is coterminal with 120 plus 360. So we'll add 360 to 120 and get 480. So these are coterminal. Could add 360 to that and get 840. Those are coterminal, and you can keep doing that. You can just keep adding 360 degrees. And these will be coterminal angles. The kind of interesting and different side of this is we can actually have negative angles. Negative angles are formed by rotating the terminal size clockwise, so in this direction, rather than counterclockwise, which creates a positive angle. So coterminal angles include some negative ones, and we can get to negative coterminal angles by subtracting 360. So if we take our original number and we subtract 360 degrees, 120 minus 360 would give us negative 240. And as you see in this diagram, negative 240 degrees is in the same spot, the terminal side is in the same spot as positive 120 degrees. And you can keep going down, keep subtracting, so minus 360, negative 600. All of these angles will have the same sine, cosine, and tangent because they are the same triangle will be formed. So let's go ahead and look at another example. First we're going to start this side. We want to find 5 coterminal angles of 60 degrees, and at least 2 of those must be negative. So we're going to start with 60. Let's find our 2 negative degrees first. So we're going to subtract 360. And when we subtract 360, we'll get negative 300 degrees. And we're going to subtract 360 again. We'll get negative 660. So right now we have 2 coterminal angles, negative 660 and negative 300. And now we're going to find some of the positive coterminal angles. We're going to add 360. So 60 plus 360 gives us 420. So our third coterminal angle is 420 degrees. And we're going to continue to do that. Add 360, and we would get 780 degrees. Add 360, and we're going to get 1,140 degrees. And theoretically, you could keep doing this forever, and you have an infinite number of coterminal angles. So that is coterminal angles. One other type of problem that you might see is when you're given a terminal side and you're given a point on that terminal side, and we want to find either the sine, cosine, or tangent of theta. When this happens, what you want to do is create a right triangle. So I'm going to bring this side straight on up to the x-axis, and I've created a right triangle. This is my 90-degree angle right here. And now we're going to talk about this angle. I'll label it alpha. The tangent of the sine, cosine, and tangent of alpha will actually end up being the same as the sine, cosine, and tangent of theta. So if we find, using this triangle, if we find sine, cosine, and tangent of alpha, we will also have that for theta. What we want to do next is start labeling some of these side lengths. So here we have our x value and our y value. Now your side lengths can be negative. Sides, in this case, can be negative. And that indicates the direction. So our x value here is -3. So this side length is -3. The y value is -4. So this side length is -4. To find our final side length, we need to use the Pythagorean theorem. -3 squared plus -4 squared equals c squared, because that's the hypotenuse. And we end up with c equals 5. Hypotenuse is always positive. Hypotenuse is always positive. So C is 5. Now, remember SOHCAHTOA, SOHCAHTOA, sine of theta, cosine of theta, tangent of theta. Sine is going to be the opposite, which is -4, over the hypotenuse, which is 5. That can't be simplified, so we're done with that. Cosine is the adjacent, which is -3, over the hypotenuse, which is 5. And finally, tangent is going to be -4 over -3. Well, a negative divided by a negative is a positive, so this is 4/3. All right, so to wrap up, if you want to find sine, cosine, and tangent of these angles, of any angle in the standard position, you would need to draw a triangle in and find the sine, cosine, and tangent of that triangle, and then you'll have your answers. That is all.